Hello, I'm Mr. Hansell. I teach principles of technology, so if you're watching this, there's a good chance your child has me for principles of technology. It's basically applied physics. When we talk about the applied physics, I mean, in this sense, it is quite literally applied physics. We're applying the different concepts to things that these students might come across. For example, a lot of the students are involved in the CTC programs. There's a good handful of them that have automotive classes. So when we do things like the fluid work unit, we would look at the braking system of a car. And the thermal system, we look at the heating and cooling system inside a vehicle as well. So we do try to tailor some of the stuff for the students' interests. We do base a lot of the class on hands-on kind of activities. For example, at the end of the mechanical force, fluid force, thermal, and the mechanical work unit, they have a project. The mechanical force unit, they'd be building bridges. The fluid force unit, they'd be building boats. The thermal unit, they'd be constructing a house. It's not too intensive. It would be using things like manila folders for the walls, but there would be analogs for certain kind of insulation, because in that unit we'd be looking at how well a house would be insulated. We look at the heat flow rate of that one right there. So wanted to throw that one out, that we do a decent number of projects in. So when they would be seeing me in class, that's when they would be working on that kind of stuff. They had just recently completed the bridge project. Some of them have been tested. Some of them we will be testing. In the bridge project, we look at mechanical stress that a bridge might undergo as we're putting more and more weights on it. Aside from projects, students will be doing a handful of labs as well. The way the course is set up, we do like to have a lot more hands-on activity, counting for a chunk of their grade, because some of these students, they do better working with their hands. So they're not necessarily bad test takers, but some of them, they're not strong test takers. And if that's the case, the hands-on aspect of the class will make up for possibly a poor test grade or something like that. We usually do go over the labs then together to make sure there's some kind of understanding before they would submit those. Now in the class, I'm looking at the PT Physics Echo Calico document that can be found in Schoology. I believe it's in the folder First Day Materials. But with that document right there, I'll be reading off of that for this video. The course goals, I want the students to build strong critical thinking skills, problem-solving strategies, and habits of scientific thinking, to build an understanding of the wonders of the physical world around us, and to allow the students to make connections between material learned in class and real-life applications using hands-on approach. So that last one right there I'd already told you about. We do like to relate the material that we would be doing in class to things that they would be doing at the CTC, or just things that they would be interested in. And to build an understanding of the wonders of the physical world around us. That's sort of what physics is. We try to explain what's going on in the world scientifically in order to create a better understanding. So one of the things that physicists have been looking at is what makes up an atom, and then we see that there's protons, neutrons, and electrons that make up that atom, but then we say, well, then what makes up the protons, neutrons, electrons, and we have subatomic particles smaller than that, and so on and so on and so forth. So we do continue to ask okay, well, what makes that up? We like to sort of figure out how things are working in the world around us. So hopefully they get some of that in this class as well. And then the build strong critical thinking skills, problem-solving strategies, habits of scientific thinking. Scientific thinking is always a good one. I know we go over physics concepts in the class. However, I think it would be more important what they get out of the class would be those critical thinking and problem solving strategies. Some of them would be working on maybe a vehicle. Well, there's a problem with that vehicle. What are you going to do to solve that problem? So there are some problem solving strategies that do overreach, that it's not just in science we would use these strategies, but they're just strategies in general that we could use for a variety of things. And of course, we're always going to run into problems in our everyday life. It would be really nice to have some kind of strategy to deal with those. So the key instructional methods, the students will work on projects periodically through the course. I had already discussed that. There's 4 different projects they would be working on, and we'd be doing those in class. The projects help to demonstrate an application of what was learned. So, for example, I'd already discussed what goes on with the bridge project, but with the boat project, we'd be looking at buoyancy. With our mousetrap car project, we would be looking at something like torque mechanical work there by increasing the lever arm of our mousetrap cars. We can make these things go further or faster. We also have peer discussion analysis, so a lot of the times in the labs they will be in groups, in which case they are encouraged to communicate with the people in their group, as sometimes your lab mates have an answer to a question that you might have. That would be something that, rather than needing to call me over to discuss something, a lot of times by talking with their lab groups, they're able to work something out, and I feel that gives them a better understanding of the material if they're explaining it to one another, or if they would be discussing that, putting it in their own words. It demonstrates a deeper understanding of the material rather than me just coming over to the lab table and saying the answer is this and that's the end of it. But with that being said, that leads us to the third one in the key instructional methods, which is questioning. Through a question-driven discussion, students uncover physics relationships and applications. If the students are there to discover the applications for themselves, if they're working through problems with each other, rather than just being told what an answer is, they do develop a better understanding of the material, and they can possibly develop better critical thinking or problem-solving techniques as well. Definitely a plus. So for the evaluation in the class, it's pretty much the same as almost every other class. Now there's going to be unit work. That could be things like math skills, which, by the way, all the papers in this class are color-coded. The math skills are always blue. The math doesn't get really any more complicated than algebra. And even then, it's more of a 2x is equal to 6. Can you solve for x kind of deal? So it really doesn't get any more difficult than that. We also have text times. Those are their guided notes. Those are always yellow. The reviews are always pink. The reviews, I always give them at least 1 or 2 reviews before going into a test. And the labs would always be green. So I like to try to color code that stuff so it's a little easier for the students to find those kinds of papers. It also keeps them a little more organized as well then. So there's unit work. We got projects. Already went over the projects. Different labs would count, and of course your tests and quizzes. But again, looking back at it, the building projects I think are the big takeaway from the class. I want them to be able to get a chunk of their grade dealing with hands-on kind of activities. And again, that's what we hope to do while they're in the classroom, is hands-on stuff. The other thing there is the cumulative final exam. The cumulative final exam, I already told the students, it's just made up of questions that they would have seen on previous exams. So none of those questions would be a question that they wouldn't have seen before. And before the final, they are more than welcome to look back at those tests. A lot of the tests will be online through Schoology, so no matter where they'd be at, whether it be at school or at home, they would still be able to access those tests and questions as well as what they might have gotten incorrect to prepare for the final. So that's just a brief overview of Principles of Technology. I can see from the timer at the bottom that I'm running a little low on time. So I just want to end with, if you are curious as to what's going on in the class, I do have a lot of stuff posted in Schoology. So if you have access to your child's Schoology pages and such, give it a look over. I have when due dates would be, and I use that primarily for my grade book this semester at least, as well as PowerSchool. Everything from Schoology will sync over to PowerSchool. If you need help accessing Schoology, I'm not sure who you'd contact. I think you'd be contacting our tech department. You can call in the office and ask. Shoot me an email. I can do my best to help you with that. But I would say, yeah, if you're interested in what's going on in the class, take a look at the Schoology page for the course. Have all that good stuff in there so you know what's going on ahead of time. Like I said, I have those due dates going on. And of course, if you have any questions or concerns, you're always more than welcome to send me an email. It would be Hansell, CHANSELL, 2 L's, at cocalico.org, or you could give the school a call and leave a message, whatever works for you. I usually try to get back to you within the day. So I hope you have a fantastic day. I hope your students, well, my students, but your children have a very successful semester. And again, any questions or comments, concerns, whatever, please feel free to contact me. Have a good one.